Hi everyone, I'm Alex, and in this video we're going to review the first draft of the BEAM roadmap update that will cover the next 9 to 12 months of development. We're doing this today in preparation for the community call tomorrow. We're both releasing the document and we will add the link to the description below. And we're also releasing this video so you can review it and be prepared to discuss in depth all the suggestions and features that we're going to work on in the next 9 to 12 months tomorrow. And we're also going to kick off officially the 5.2, which is the next version we're going to work on, and we're beginning the planning and design of this version right now, so you can also contribute and participate in that process. Towards the end of the video, I will explain exactly how to work with the document we published and how to contribute your suggestions, ideas, and comments on this roadmap. And we will also provide time codes for each separate part of this video because we have a lot of material to cover, and it will be difficult to take it all in like one big piece, so that using the time codes you'll be easily able to jump from one part to another and review the topics that are of more interest to you. So as you can see, we have a lot of things to cover, so let's get started. So in order to make things simpler to understand, we have divided the roadmap into 3 tracks: the wallet track, the DeFi track, and the infrastructure track. And each track spans 2 major versions: the 5.0, which is the current major version, and the 6th version, which will be probably after the next hard fork that will introduce all the consensus breaking DeFi features that we will need in order to build applications on our platform. So basically, we will talk about 5.0, which was the last hard fork version, the 5.1, which is the current version we're almost finished developing and are currently testing, and it probably will be released in the next few weeks. And we will talk about all the proposed features for the 5.2, which, as I said, will be officially kicked off tomorrow. So as you know, about a month and a half ago, on July 28th, we have enabled the second hard fork, which both changed the consensus algorithm from BeamHash 2 to BeamHash 3, and also introduced infrastructure support for 2 very important features, which are Lelantus Wimble and confidential assets. So once we have released the 5.0 version, we have immediately started working on 5.1, in which we are adding to our UI wallets the ability to use these new infrastructure features. And we have started with Lelantus, which provides us 2 very interesting and useful features. The one is called max privacy transactions, and the other one is offline payments. So let's talk about them a little bit in depth, because they also have an impact on our future plans in 5.2. So we did release previously videos and explanations and articles about these features, but I would like to take this opportunity to review them again a little more in depth, so we understand what our constraints are and what our options are in different aspects of these features. And we will start with the max privacy transactions. So the idea of the max privacy transactions is very simple. It's a transaction that basically has 2 parts. The first part of the transaction, the sender takes the input UTXOs and commits them to the Lelantus shielded pool. And then once some time passes and the anonymity set accumulates, the sender can take them out of the Lelantus pool, and now he has a completely new set of UTXOs which are unlinked from their previous history, and thus cannot be linked to any other transactions that they have came from in the previous iterations. In the 5.0 version, this feature is only supported in the CLI, the command line wallet, and it is exactly like I said, 2 separate transactions, one that puts the UTXOs in the pool and the other one that takes them out. In the UI version of the wallet, we have wrapped this functionality using the regular send and receive dialogues, so you can decide whether you want to send or receive funds using the regular Wimble or the max privacy transactions through Lelantus shielded pool. Whenever the sender commits the UTXOs to the pool, the send operation is complete, and the receiver is immediately notified by monitoring the blockchain that the funds are currently in the pool and belongs to him. And at that point, the receiver can decide when he wants to use these funds. And of course, it's recommended to wait for the maximum anonymity set to accumulate, and the time for how much time this takes, it depends on the usage of the pool. And the wallet monitors the situation and shows you for each of the UTXOs how much anonymity set it has gained in the pool. But you don't really need to worry about that, because the wallet automatically tries to select the most safe UTXOs for each transaction, and it can also mix UTXOs from the pool with the regular minimal UTXOs in single transactions. So basically there is no need to take the UTXOs out of the pool. You just create a new transaction and all this is taken care of automatically. And this is very convenient, but of course the more you wait, so the better anonymity set you gain for your UTXOs. Lilantos Mimblewimble also allows us to create one-side payments that we call offline payments, because the receiver can be offline when this happens. And here we have two different possible implementations for this feature. So the first implementation is working just like Bitcoin. You create an address and you can send this address to anyone, and from now on you can receive funds to this address at any time from anywhere without having to be online at the same time. So this approach is very similar to what people are really used to from other cryptocurrencies. But because of the nuances of Lilantos implementation, it has several disadvantages. The first one is that you cannot create an infinite amount of such addresses, because once you have sent this address to someone, you need to monitor it indefinitely, because you might receive funds to this address at some point. And the more addresses you have, the heavier this operation becomes. And the cryptography involved basically does not allow for existence of too many simultaneous addresses in the same wallet. It will just be very slow and will eventually stop working. Which is why you are kind of limited to some relatively low amount of addresses. And this gives us the second problem, because once you send the same address to two different people, they might meet at some point and compare the addresses and understand that this is actually the same person. Another problem with this schema is that the sender can monitor the blockchain and see when the receiver has actually spent the funds or taken out of the pool. The second approach is a little bit more complicated, and it involves something called vouchers, which are basically one-time addresses which you can send to someone, and then each voucher is good for one single offline transaction. So let's say somebody receives 20 vouchers, he can now make 20 offline payments to you, but after that he will need to restock the vouchers, and we have provided two possible ways to do that. The first one is automatically, once your wallet is online and somebody needs your new set of vouchers from you, you will receive an SBBS message, the wallet will automatically create a new set of vouchers and send it back. And if you're not online like ever, basically someone can ask you to give them a new set of vouchers, and you will just go into the receive dialog and create a new set and send them via Telegram or any other messenger, basically outside the BIM system. So it sounds complicated, but this schema actually has several privacy advantages, because as I mentioned, each voucher is unique, so there are no way to de-anonymize you using these vouchers. And also the sender cannot see when you spend the funds. So once the send operation is complete, the sender is no longer able to monitor these funds. And this is the schema that we have actually implemented in 5.1. And now, as we're starting to plan 5.2 version, we will probably add the second possibility, because it does cover some cases that the vouchers miss. For example, donations. If you want to just create some address and publish it on your website so people can donate beams to you and you don't have to be online to receive them, you will probably use this one single address for all the donations, and it will be very convenient. There are also other possible use cases, like for example, payouts from pools, which sometimes require permanent address that they can send at any time without you having to be online to receive them. Another improvement that we have added in 5.1 is improvement in atomic swaps, where we have replaced the intermediate outputs of Bitcoin transactions with SegWit, and this allows to reduce fees considerably. And also we're currently in the previous version, you needed to set the fees manually, and now we have created a mechanism that retrieves the fees, the current fees automatically from the blockchain and provides them as a minimum recommended value. So you can set higher fees, but you cannot go lower. And thus you will avoid the potential problem of your transaction being stuck because the fees are too low suddenly and the transaction is starving somewhere and you cannot complete your swap. So these two improvements are already built into 5.1 and are being tested right now. In addition to that, we have also refactored the settings screen because now we have a lot more features. So we have organized the settings in easier to use way and grouped them together according to their meaning, like all the features related to the wallet in one pane and then all the features related to the connectivity in another. And you have also have a group of settings that are related to troubleshooting and collecting your logs and all the rest. And we plan to extend this screen in the future with additional panes as we have more features that need configuration. So now let's move to the 5.2 version, which will be officially kicked off tomorrow. And let's talk about the possible features that we can add there. And we will start with the Beam Vault. The idea of a Beam Vault is new. It's the first time you probably hear about it, but it's very simple. Currently, we have an SBBS system, which allows wallets to exchange encrypted messages, and these messages live in the system for 12 hours before they expire. And the reason for that is that we do not overload the system and it does not have to store too much information. But there are also downsides, of course, to this approach, because if you have been offline for several days and somebody tried to send you a message, you will never receive these messages when you come online. So Beam Vault is basically a centralized but trustless component that can store SBBS messages for longer periods of time and then rebroadcast them upon request to you. So you basically ask for a specific time range for a specific channel and you receive this broadcast of messages that were happening during the period that you were offline. This can be useful for several cases, and this can be especially useful in the future for DeFi applications. It's still not clear exactly how to implement that and which constraints should be there, but that's the general idea that we will be discussing. Another very useful feature that can be implemented using such a system is the ability to synchronize several different wallets that run on several devices with the same seed. It's an old problem that most of you are aware of, and we have always recommended not to do that, not to run different wallets with the same seed on different devices, because when the transaction arrives to one of the wallets, the other wallet balance will be updated, but the transaction list will not. And then you will have a discrepancy between the transaction list and your current balance. So once we have this centralized trustless component that the wallet can connect to, we can send information using this account, which is obviously completely anonymized, just basically a long string of numbers that kind of identifies your wallet identity maybe. And then you are able to synchronize these devices using the mechanism which is similar to SBBS, basically encrypted messages between the wallets. And once the wallet comes online, it will receive all the information about what happened on all other wallets, and it will be constantly up to date to the latest history of transactions and all the balances and everything that happened in the wallet. Another useful feature that we're thinking about doing in 5.2 is improving the address book. So in the older versions of Beam Wallet, the address book was already present, but it was hardly used because in most cases, people used one-time addresses to send funds from one another, and rarely doing like repeated transactions using permanent addresses. Usually it was pool payouts or exchanges. So the address book was there, but it was hardly used. Now that we have Lilantus and we have all the new types of transactions, including offline transactions, so then you receive a set of vouchers, for example, like you do in 5.1, and it probably would be useful to create some kind of an entry and create some kind of a label for these vouchers, so that if you want to do several offline payments to the same person over some period of time, you can easily find them in the address book and perform the payment, because you don't need him to be online at the same time. I think the address book will also be useful for other features, and probably it will be useful in the future for DeFi features as well. So this is also something that we're talking about and thinking about redesigning and improving. One of the problems why we did not do it before was because, as I said, probably would not be as useful because most people use the one-time tokens or one-time addresses till now, but also because it does store some personal information, or the labels, even though they can be somehow obfuscated, probably do disclose some information. So privacy-conscious people do not use address book probably at all, and this is some concern, which both introduces an additional metadata into the wallet, which is something probably not the best thing for privacy, but it also interrupts the user flow. So for example, when you receive the token, the address, I'm sorry, we gave up the token name, I'm still getting used to it. But when you receive the address that contains several vouchers, you will probably need to add a label during this creation of the transaction, and kind of interrupts the transaction flow. Of course, we can always edit later, but all of these UI-related and UX-related discussions are something that we need to have in order to create the best and the most usable solution. The third topic that will probably be released in 5.2 is the support for Trezor T. So Trezor has commented that they are not going to officially release a firmware with Beam support, even though we have developed it and submitted the pull request. So we're currently left with an option of releasing a custom Trezor firmware that supports Beam. And we have almost completed the wallet integration. There are a few minor bugs that are still out there, mostly in UI components. So this is something we've been putting away for quite some time, and now in 5.2 I think we can finally get to it and finalize it and release it, so that if you want to store beams on a Trezor T using the custom firmware, which will be signed by us but not the Trezor, you will be able to do so. We did a lot of work on both Trezor and Ledger. The Ledger work is still in progress and it's moving along. It's slowly but surely it will be there eventually. And we have created a lot of internal infrastructure components for that. And I think once we release it, it is something that will be useful for a lot of people. We had a lot of requests about this feature from the community. So I think 5.2 is a great time to finally complete and release this feature. Atomic swaps will get some additional coins we will support in 5.2. Basically the code is already developed and all we need to do is to test it and integrate it. And we're talking currently about the BSV, the BCH, Dash, and probably in the future Ravencoin. All of them are forks or clones of Bitcoin, so which is why we can integrate them relatively easily. And this is something we also plan to roll out in 5.2. Another thing we're considering is to add more information to our blockchain explorer, especially about the atomic swaps, which currently have no statistics. So you can see the current swaps which are offered in your wallet, but you cannot see the statistics of how many swaps there were, what were the rates that the coins were swapped at, or like what's happening with the swaps. And it's relatively easy to add by monitoring the SBBS messages that are exchanged between the people who are offering or accepting the swaps. Of course, we cannot know whether the swap actually took place without monitoring the Bitcoin network directly, but at least it will give some indication which swaps were accepted, even though they might have failed because of technical reasons or any other considerations during the swap process. Maybe somebody canceled in the middle or something like that. But still, it will give us some statistics on how much swaps are used, at what rates, and how many fees are actually paid, because we believe that these swaps are quite an efficient way to exchange large amount of coins in terms of fees. So this is something that will be very nice to display in our blockchain explorer. Another thing that we feel is important to display in the explorer is the current status of the Lelantus pool, how many UTXOs are there, and what is the rate of growth of the anonymity set. So basically, how much time will you have to wait, on average of course, to achieve maximum anonymity when you put your UTXO into the pool or do this max privacy transaction. So these are several of the improvements, and probably there are also additional ideas we might think about to add to the blockchain explorer and make it more informative and more useful. As I mentioned, in 5.0 we introduced the confidential assets. So basically anyone can create a new type of asset on Beam network today by locking 3,000 beams and registering this new type, and then being able to emit any amount of new assets that are completely indistinguishable from Beam itself. They're all confidential and scalable and work exactly like Beam. Using native transactions, you can also exchange one type of asset for another. You don't need any swaps for that. Basically, the same transaction can send any amount of different types of assets, including Beam, and receive back any amount of assets as well. So it all works on the same level as the Beam transactions. And currently, this is the feature which is supported in command line wallet, but we of course need to add this to our UI wallets as well. The reason we prioritized Lilantus over that in 5.1 was because there are still no meaningful confidential assets on the Beam network, so we thought about making the UI changes for Lilantus first and then moving on to the UI for the confidential assets. And 5.2, once again, is a version where we might implement that. Of course, once we talk about the DeFi ecosystem and DeFi platform, all of these features will be very useful because you will have this unified view in your desktop or mobile wallet, which will present all the different currencies that you can trade in all the different ways. So regardless, we will need to implement these UI features sometime in the near future. So maybe 5.2 is a good version to start working on that. The final thing that we will discuss in the context of 5.2 is a proposal to what we can finish or what we can continue working on is the web wallet. As you know, the web wallet and the wallet service, which is the backend, also a centralized and trustless application that runs on the server and is able to support simultaneously multiple wallets. So the web wallet can connect to it, create a connection, and then send and receive transactions from your browser or from any other client that connects directly to the web service. So this is something we released to testnet recently, and we have released several tutorials and articles and reviews of that. But there is some distance that still needs to be covered before it can be released to mainnet, mostly related to security and scalability. So what happens if there are a lot of clients, how does it scale, how secure it is, not internally, not from the point of losing manual information, but rather how easy it is to DDoS, how we protect against that, and all of these DevOps and system architecture related questions were not completely answered during the testnet phase because we wanted first to see the functionality, to feel it a little bit, let the community play with it. And we also needed the APIs in order to be able to contact other wallets and offer them to integrate Beam, which was something that we wanted to do for a very long time, but it was always problematic because of the interactive nature of Mimblewimble and the different cryptography that it uses. So we hoped that introducing the wallet service would simplify some of these integrations. So this is why we have actually released the testnet even before we have solved all the scalability and the security issues on the system level. So this is also something we definitely need to finish at some point in the near future, and once again we can do this or start working on that in 5.2. So this so far was the wallet track for the 5.1 and the 5.2 versions. As you can see, we have quite a lot of tasks to prioritize and to choose from already. Some of them are not trivial, and some of them require a lot of usability and UI work to make them as usable as people are expecting from our wallets. And now let's switch to the next track, which is the DeFi track. It's also very interesting and has a lot of new stuff. So let's talk about DeFi. We will start our discussion of DeFi with description of two different types of architectures for our confidential DeFi platform that we are developing right now. So the first type of architecture is something that we've been talking about for a while, which is modification of the scriptless scripts idea. And the concept of this architecture is that the wallets communicate with each other directly in order to create different types of financial agreements. And then once these agreements are created, all the transactions are performed directly between the wallets using, for example, our laser beam direct payment channels. And then at settlement time, the settlement is actually done on-chain using all kinds of cryptographic elements like Schnorr adapter signatures or other types of math that allows you to verify that the final result of your agreement actually does not violate the current state of the blockchain. And for that we utilize extensively our SBBS subsystem so that wallets can publish information, exchange information, and use these encrypted messages to basically agree on some contracts and then start interacting on these contracts. Like, for example, one of the applications that we have been thinking about to implement first using this architecture is the idea of perpetual swaps. So perpetual swaps are kind of futures contracts in which two parties agree to pay each other depending on some price of some underlying asset, for example, Bitcoin. So if there are two players and one is long and the other is short and the price is rising, then eventually the one that was correct in their prediction will pay the other side, and basically that's how the futures work. Of course, in our case, the settlement will be a kind of cash settlement in Beam. The collateral will also be locked in Beam. But this kind of application is possible to implement using the scripted script architecture. And of course, it's much more nuanced than that. There are also funding transactions that need to be sent between the parties to balance the price of these contracts. And these contracts can also be resold. So for example, if two parties have a perpetual swap contract and one of the parties wants out, it can try to find another counterparty for their side, settle, and then basically transfer their side of the perpetual contract to third party, to another player, and then get out of this deal. And we have tried to model this, and we have run into some difficulties in implementing the punishment mechanism in our current laser beam implementation. But this is something that can be solved. And this would be a very nice first kind of DeFi application on Beam platform that completely uses only the script infrastructure. Of course, there are many other possible applications that can be developed, but all of them have one specific flaw or limitation, that they're all kind of P2P interactions. So the players always interact directly using the SBBS system, and they don't really need any smart contracts or any smart contract-like components to handle these trades. And this makes certain applications not possible to implement. However, recently we have been thinking about a completely different approach, which is the second architecture I would like to discuss now. And we call it the Beam script or Beam contract. And the idea is that using one of the interesting features of Mimblewimble, namely the kernels, and tricks similar to what we've been doing in Lelantus, Mimblewimble, and also in atomic swaps, what we can do is create this transaction which consumes input UTXOs, but instead of creating output UTXOs, it actually updates state variables inside the node. And these state variables can be then combined into a contract, which can have some script that can operate on these variables and perform different calculations. So all the transactions are confidential. The script itself is not necessarily confidential, and there are several interesting tricks using homomorphic cryptography, and there are also more advanced approaches to make the calculation itself completely confidential, so that the node which is performing the calculation does not know exactly the numbers that this calculation operates on. But in any case, This approach is much more flexible, much closer to what people are used to in other smart contract platforms, and it opens the idea of confidential DeFi to a much wider range of application, including lending and getting percentages on your funds, and all kinds of liquidity mining and other terms that describe this idea of lending liquidity for certain predetermined percentage. And basically it will be conceptually exactly like smart contract, but running inside the node with a limited script, which will be faster, more reliable in this way. Of course, as a result of these transactions, the script can also do certain operations, like for example emit new types of confidential assets as a result. So you have these situations where you put some collateral and you get back some tokens which represent the collateral that you've put, and then you can trade these tokens, as we see in many current DeFi applications like Compound and others. Once we have this functionality, we are basically on the same playing field as other smart contract platforms, but with the built-in confidentiality and usability, of course, and scalability, and it's fast. So there are a lot of advantages to this approach, which is why we have decided to start working on this concept immediately. And one of the first things that we will begin doing, starting with the 5.2 kickoff, is creating the proof of concept of this approach of BEAM contracts, which will provide this showcase of how this can work using some simple smart contract at first, with several state variables that are operated on by the scripts. We are still to design and to specify exactly how the script will be laid out and how it will work, but this is something that we will start working on right now. So this is something that we want to be starting on right now, and we believe that it's something that the first results there can be achieved relatively quickly, maybe within a month. And once this concept is proved possible and viable, we can start releasing SDKs and specifying APIs on how we can interact with these contracts. And of course, combined with the SBBS and the script-to-script approach, we receive this very rich infrastructure that basically can be used to create almost any type of DeFi application, whether it's confidential stable coins or confidential lending or trading, including DEX-like experience where you can trade different types of assets one for another. And once again, on BEAM, confidential assets are tradable within regular transactions, so there is no need for swaps. Anything can be traded for anything using the same transactions as BEAM. So it will be very convenient, and of course built into the wallets in a seamless way, so that you have this experience of having different coins, different assets, and different applications all in one place. And this is something that will be definitely a killer feature. So this is like the first point, BEAM contracts in addition to script-to-script, something that we think we will be working on immediately with the kickoff of 5.2. Another thing that we will definitely need for any DeFi application is oracles. And in BEAM, there could be technically two different types of oracles in a way, because for the script-to-script applications, we can use the oracles that work through SBBS and deliver the information about the rates of the assets that are being traded directly to the wallet. And the wallet may receive information from several oracles, compare it, and decide which information it wants to consider for their transactions or for their financial operations. And this is completely off-chain, so the user basically decides whether the information provided to him is relevant. It's a little bit similar to the experience that we have currently on exchanges. So basically, when we trade on a centralized exchange, we're provided with some current information about how much this asset is worth, and we have to trust this information. The difference is that in our case, we can compare information from different sources, and it will be reliable and stable, and if one of the sources for some reason is off for like any security breach or any technical problem, there are always other sources of information that you can use instead. And of course, once the two players create some kind of financial agreement, they both agree to use the same set of oracles. And these negotiations could be hidden nicely behind the SBBS API, and thus provide very, very smooth experience. The other type of oracles are the oracles that provide information on-chain. And these oracles are important for the smart contracts that operate based on the data provided by these oracles independently of any user intervention. And in this case, we need much more robust oracle infrastructure, of course, because there are no longer ability for the user to decide whether that information was correct or not. The smart contract makes decisions automatically based on the provided information. And here we might consider either developing our own implementation or maybe integrating with one of the currently known and reliable oracle providers. So any approach is acceptable as long as it works and works well, but this is something that we definitely need in order to be able to trade anything on our DeFi platform. The last thing that we would like to talk about in the context of DeFi Track is the idea of sidechains. And this is something that will probably take more time and will be planned for later versions like 5.3 and above. But sidechains are a very powerful extension mechanism, and the way they can be built in Beam is basically by using the same Mimblewimble core, but taking other types of consensus algorithm, for example, like maybe proof of stake or like other similar consensus mechanisms, or maybe doing even GhostDAG or any other algo, but still be able to move assets seamlessly from Beam mainnet to the sidechain and back. Once we have this capability, we can, without affecting the Beam mainnet, create new sidechains, and these sidechains can either have their own native token, which is mined or created in some way, or they can be completely empty and then co-mined or merge mined with Beam, and then we can move value from Beam mainnet to these sidechains and use the special features of the sidechains, like for example speed or any additional features that can be provided, and then conduct trading there and move the assets back to Beam mainnet and sell them from Beam mainnet, for example. It's a little bit like this Polkadot concept, when you can construct many blockchains that interact with each other. And the way it will work is by basically using this fly client concept. It's just like SPV client that we have built into Beam wallets to monitor the concurrently running sidechains. So at each point, Beam mainnet is aware of which sidechains are currently running, and the sidechains are obviously aware of the Beam mainnet, and they monitor each other's state, and it is possible because all of them are Mimblewimble at the protocol level. So this concept is probably will take longer to implement. There are some interesting challenges there, and we believe that at least for now it has less priority than other things that we have previously discussed. But this is also something that we want to put on our roadmap, probably at 5.3 or maybe later milestones. The last track that I would like to cover today is the infrastructure track. The infrastructure track currently contains two very, very important tasks. One of them is bridges with Ethereum, because even though we'll have a lot of features within the Beam network, still a lot of DeFi applications run on Ethereum, and there are a lot of tokens there, and it would be amazing to be able to create wrapped assets on Beam that represent value which is locked in some contract on Ethereum, and be able to trade it confidentially, and then unlock it and move it back to Ethereum and continue working with it there. And initially, when we discussed these possibilities of how to create these bridges, we mostly talked about federated bridges. And the idea of a federated bridge is just basically a wallet which is controlled by multiple parties using multisig. And at the opposite Ethereum side, there is a smart contract which locks the value which is represented then as confidential assets on Beam and is controlled by this federated wallet. This is simple enough concept and simple enough architecture to implement. However, there is always an issue with trust and trust minimization. So instead of just relying, even though it's like federated, relying on these several parties that control the wallet completely, in most cases, this is too much trust to give, especially when large amounts of tokens are involved. And which is why we believe that right now that this concept, even though it's simple, will not be sufficiently trustless for most useful applications. And we would like to start from a more difficult concept to implement, which is decentralized bridges. And the idea of decentralized bridges is complicated because each node on the Beam network needs to be aware on some level of the state on the Ethereum network, maybe a specific contact on the Ethereum network. And this also can utilize this concept of an SPV client or fly client that we have to only retrieve the information needed to verify a specific state and get sufficient proofs that this state is consistent, and also from the other side, from the Ethereum contract, be able to retrieve and analyze the current state of the Beam network. So if we're able to do that, we can create decentralized bridges, and combined with the Beam contracts idea that I've previously described, we can actually create something amazing, a completely decentralized bridge that can move value from Ethereum to Beam and vice versa, and of course will support confidentiality when being traded on Beam. So think about taking a stable coin like DAI and being able to move it to Beam and trade it confidentially, and then when needed move it back and sell it on Ethereum or do any other operation with it. So we think it's a very strong and powerful concept, and this is also something that we would like to start investigating and researching right away, right from the beginning of 5.2. So this is something that could be really awesome. The last task in the infrastructure track is the research and development of GhostDAG. GhostDAG is a protocol for creating a blockchain which is not actually a chain, but rather a directed acyclic graph with some number of simultaneous chains that can branch out from each node or from each block. And the reason it's an interesting protocol to consider is for several reasons. First of all, the confirmation times are faster, blocks are created faster, and thus the throughput of the network is much larger than currently we have on Beam. And also it creates more fair reward distribution for miners, allows individual miners and not pools to gain more influence on the network. And it also basically creates more democratic spread of mining rewards. So if it works, and we're currently in the early research phases of this protocol, there are no mainnet implementations of this protocol out there right now, but there are some companies that develop this idea, specifically of GhostDAG. But we believe this can be very interesting improvement for Beam, either as a sidechain or maybe far away in the future as a mainnet if this proves to be a good solution. So this is also something that we're also working on right now immediately and concurrent with all the other things that we have discussed. So let's take a look at what we've got. So we have the 5.1 version, which is almost near completion, and tomorrow we will discuss and kick off the 5.2 with all the tasks that I have presented here today as possibilities for immediate development. I think that during this video I have also stated my personal preferences in a way, and kind of emphasized which features I think are good to develop immediately, and rather than push them towards further versions. But of course everything is debatable, and I really encourage you to look deeper into these features and think about what can be added or improved. This is not the only list of features that we have, of course. We have other, let's say, not less important, but smaller features that will appear in the document at the bottom as this like list of things that got left out. And some of them are really interesting, so please take a look at them as well. And once you've done so, please follow the next part of this video in order to be able to contribute your ideas and your suggestions to our roadmap and also review the current state of events. So in this last part, I would like to show how you can work with this document and how to contribute your ideas and suggestions and comment on issues. So as you follow the link that is appearing in the description to this video, you get to our GitHub repository, to the roadmap repository, which we created, and it also appears on the main page, and it's actually pinned in the short list of most important repositories. And here you can see the document that describes everything that we have been talking about in greater detail, so you can review this and relate to all the subjects discussed here and also covered in this video. Then you can click on the Projects tab, and here you will see all of the projects separated by tracks and the release versions as we have discussed. So for example, if we go to the wallet track version 5.1, you will see that we have several tasks here that we are already working and they're almost complete in 5.1. So for example, the updated settings dialog is currently in progress, so I can move it here. The same goes for offline transactions and the atomic swap improvements. So let's say you have some idea which is related to the offline transactions. So you click on this task and you can open it in a new tab. And here at the bottom you have the comment section. So you can write your comment here. And you can click on comment and submit your comment to the task. So we will receive notifications on each such comment and we will review them and answer. And then every once in a while we will release organized updates on all the discussions that were taking place about each task. So the same goes to, for example, the DeFi track for 5.2. All the tasks related to DeFi track will appear here together with their status. The same goes to the wallet 5.2 track, which has all the tasks that we have discussed about this. And in addition to that, you can also submit your own issues. You can go to the document here and you can submit pull requests by editing this document, creating a fork of this repository and then changing whatever you think should be added or replaced in this text and submitting a pull request to merge the changes, and we will review them and accept or decline the request. And this is going to be our dashboard that will allow us to monitor what is currently going on in the project on a high level. We will attach all the necessary documentation, whether this is designs of new screens or additional issues, or maybe we'll reference the specific implementation issues that appear inside the projects that the developers are working with. And all the information will appear here in an organized fashion. And this is how we will try to create discussion around these topics, vote for them, or add additional information where required, and also receive your feedback and ideas.